are always surrounded by a tempest of events constantly unfolding around us. The intricate dance of countless factors behind each event is something scientists reveal to us through their captivating experiments. In my childhood, I didn't fully understand these phenomena, but my curiosity drove me to seek answers. Over time, I have tried to figure out many explanations.
Today I would like to share one such experience with my students as I understand now. I came to understand the correct explanation of this phenomena during a workshop conducted by our honorable scientist, said Dr. Ravindra Mukherjee. Now we will follow the step one by one. Please stay with us until the entire demonstration.
Here's a fascinating experiment to understand the magic of air pressure. First, we are going to take a vessel and light a candle over it. Now we are going to pour some water over the vessel. We are going to add some color to it. Now we are going to take a glass and place it on top of the candle. Now let us observe what is going to happen. We see the candle is flickering and it slowly goes out. Along with that, we also see about 1/5 of the cup has been occupied with water. You might have come across this experiment several times, and the explanation that we have received is somewhat like this. When the candle is covered, it uses up the oxygen, creating carbon dioxide, which dissolves in the water. This lowers the air pressure inside the glass, causing the water level to rise approximately up to 1/5 of the glass. Hence, it was concluded that the water rises up to 1/5 of the glass due to the combustion of 1/5 of the air, which is oxygen. This experiment that we just performed satisfies the explanation that we already know. However, the experiments that we are going to perform further are going to contradict the explanation.
Now, we place 3 candles close together and a single candle on the same dish. Then perform the same demonstration again using 2 identical glasses. With 3 candles, the water level rises more than 1/5 of the glass. The glass that covered the 3 candles showed a significantly higher water rates than the one covering the single candle. Additionally, the burning times of the candles in the 2 glasses differ. Why does this happen? Both glasses have the same volume, meaning they contain the same amount of oxygen. An equal amount of oxygen should be burnt to produce an equal amount of carbon dioxide. Therefore, it can be concluded that the limitation of oxygen is not the sole reason behind this phenomenon. But wait, there's more. Now for a twist in this mesmerizing magic show. I lit a candle in a dish and kept a wet glass on top of it for a while. Now, without covering the candle, place the glass on the water next to the candle. Wow! The water starts to rise inside the glass. Here's the mind-bending part. The candle is burning outside the glass, but the combustion is happening inside. Talk about a magical phenomenon. It's almost as if the candle decided to pull a disappearing act and teleport its flame inside the glass. Pure amazing, right? Now let's discuss the phenomenon of carbon dioxide, which dissolves in water. While carbon dioxide dissolves in water, it does not dissolve in mustard oil. This suggests that the observed incident should not occur in mustard oil. But let's see what actually happens. Interestingly, this time too, the oil rose in the glass. So, were we wrong in our initial assumption? It appears that the water or mustard oil rises up in the glass, even if the candle is not covered. This indicates that the phenomenon is not related to oxygen, carbon dioxide, or combustion. Instead, it is driven by the influence of heat. Air is required for combustion. Let us understand what is truly happening. When we place a glass over the dish without lighting a candle, we observe that the air pressure inside the glass pushes the water around it. This creates a dry area under the glass on the dish, which happens so quickly that we might not notice it immediately. As the candle burns, the temperature of the air above the flame rises slightly, causing the air density to decrease as the molecules spread apart. When we cover the burning candle with a glass, a density difference is created between the air inside and outside the glass. The candle continues to burn for a short while. With the candle inside the glass at a lower concentration, heat is still being generated causes the pressure inside the glass to increase again. According to Bernoulli's principle, air escapes as bubbles to equalize the excess pressure inside the glass. This process occurs so rapidly that it can be difficult to notice. Finally, after the candle goes out, the glass begins to cool down. As the air bubbles inside the glass starts to cool, they get closer together, causing the air pressure inside the glass to drop. This lower pressure pulls the water from outside the glass into it to equalize the pressure difference. The longer the candle burns, the more heat is generated, creating a greater partial vacuum. This means more water will rise into the glass. In essence, many fascinating events are happening simultaneously in this experiment. It is a captivating display of science in action, almost like a magical show with invisible forces at play. The moral of the story is that true learning happens when we engage both our sight and senses. Through this experience, I realized our understanding deepens through a blend of philosophical insight and rational thinking.